So your quiz on Friday, question number 1 will be the graph. Find the limits by looking at a graph. Remember we had that freaky looking graph, you know, this kind of thing going on, okay? And this is 2.2. So if you're thinking about doing homework, somebody emailed me and said, you know, can you put the due dates in my math lab? And I probably will this weekend, but everything will be due probably 9/21, okay, probably through 2/3. But if you haven't done 2/1, because you know you ain't done nothing, I probably wouldn't spend time on it this week. I would do 2/2 because that prepares you for the test. The second thing I'm going to ask you to do is find limits. And remember, we said right now we only know 3 ways to do that. Plug in the value. In other words, as x goes to 3, plug in 3. If you can't do that because you end up dividing by 0, what did we do? We said, well, let's factor. See if we can factor, cancel things out, and then plug in the value. And then the last example we did was with the conjugate. So you will have one of each one of those, and which always kind of goes back to you end up doing those same 3 steps. The third thing is what we're going to cover today, which is called, I tried drawing a sandwich in my 8 o'clock class, but you know, they don't get me at 8 o'clock in the morning, is what's called the sandwich theorem. And I will show you an exact problem like that. So these are your 3 questions. Now, you're probably looking at this saying, my gosh, we only had 1 question. And I don't know, you guys need to kind of tell me, you know, how you're doing. You know, is everybody still sitting here trying to finish the quiz? Is she not giving you enough time? And I know you haven't taken enough quizzes to know that yet, but tell me, you know, and then that way I can tell her, instead of 20 minutes, you know, give them 30 minutes, you know, whatever I think you need. All right, so this is going to be what's on your quiz. Again, I've mentioned this before, my math lab has that study plan if you want to work more problems. If there's a problem that you just have no idea, and it could even be in the study plan, ask my instructor, click that button. Now, Monday through Wednesday, I probably won't have time to make videos because I'm going to my class. But if you send it to me today, I'll probably make the video Thursday. Okay, so I'll get it to you before you have to actually take it in your lab time. Now, what I would do, and I realize, you know, everybody's scared of the TA, I don't know why. I would come in and I would have, you know, pick different people, you know. I would have each one of these. I would make her work these. Even if you think you understand it, make her work these. You know, use your time wisely with her. Otherwise, what happens is she comes in, and she has the quiz, so she's going to probably work some of these anyway, okay? But then that way you can say, well, this is one I needed help on. And I mean, I'd bring laptops, you know. You work your My Math Lab during lab time. There's nothing wrong with that. All right, so let's go to, this is a continuation. Oh, I'll just try to impress you. Problem is I don't have, I guess I could change colors, so there's my tomatoes. Let's just have blue lettuce. Sometimes that happens in your refrigerator, right? It's a sandwich.
It's a beautiful sandwich.
Thank you, you get an A. All right, so this is continuing 2.2, and we will finish it today. That's pretty good. Hold on. Take a picture of that. That's frameable. All right, got it. Okay, so the sandwich theorem is, let's just, because I think a lot of times you get this if you look at it visually first. You have this function. You have, say, this function. And you're interested, you have data here, and you have no idea what that function is. So in other words, say in the past, you did experiment 1 and experiment 2, and you know what the actual functions are. Here you have data, and you're interested in, that's my interesting point, of what's going on with my blue data. Well, as hopefully you can see what happens, this is like your bread is sandwiched, and this blue's like the meat. don't eat the meat if it's blue though, is you're being sandwiched in between these values. This is a very important theorem because this is what happens a lot is you have data, and if you've never had like a modeling class or a statistics class, you may not know how to model this into an equation. I mean, if you have an equation, you find the limit of it, and that's fine. Or it may be something you can't find the limit of, but you know the limit of these. So that's in a roundabout way. Now let's do the theorem without the meat. That was a joke. Ha! Theorem. Extra credit. Extra credit if you laugh at my jokes. All right. All right, that guy's creeping me out. At least he's by the door. I don't know if that's a good thing. All right, so. I would be. All right. So suppose g of x is less than f of x is less than, ooh, got it to fit, h of x. Just stop right there. When you're reading these theorems, you're reading math stuff. Well, that's that. This could be my g of x. The blue could be my f of x, and that could be my h of x. That's value of function. That's not calculus. That's just saying that value's in between, the value of the function is in between the other two functions for all x. What that means is if I'm going way out here, this is not coming back down and crossing.
What's that V with the line mean for all?
The V with the line? Oh, for all. Well, if you paid attention the last class. Huh? For all. Yep, so for all x. What happened?
I think you have it mixed up. You said g of x is less than or equal to f of x, and g of x is greater.
HG. Yeah. So in other words, one is going to be on top of the other, the f of x, one's going to be below it, and they're never going to cross. That's what the for all x is. So in some open interval, okay, so now I'm saying, well, let's just see right there. We just have some interval that we're interested in containing, they use C, you see me use x naught a lot, containing C, my point of interest, except possibly at x equals C itself. Again, the very important part with the limits is that the value that we're interested in may not even be in the domain because of that whole deal dividing by 0, but it's near it, it's around it, okay, in this interval. Then suppose also that the limit of g of x as x approaches C equals the limit of h of x as x approaches C, that these are equal. They equal some limiting value. Then, the one that's sandwiched between them, the limit of f of x as x approaches C is going to be the same value. So I know you're writing, but I see the graph better to me that says, well, what's a limit? That says, as I'm getting close to this value, very near this value, what is my function? What's happening with my function? Well, if this f of x is sandwiched in between them, then they're all going to the same, they're all getting near the same value. So I said, guess what? This will be one of your questions on your quiz. So let's do an example. If the square root of 5 minus 2x squared is less than or equal to f of x is less than or equal to 5 minus x squared, all that's under the square root, and I'm looking on a particular interval, okay, from -1 to 1, and I close this interval. And the reason why is because they're square roots. I want to find what the limit of f of x is as x approaches 0. So this would be exactly, well, of course not the functions, but what you'll see for number 3 on your quiz. So a lot of times, I don't remember if I told you to use the sandwich theorem, but a lot of times when you look at this, you can kind of see that's what's being implied. Well, find the limit of f of x as x approaches 0. I don't even know what f of x is. So what I'm going to do is I'm going to say, well, let's find the limit of this one and this one, meaning the limit of the square root of 5 minus 2x squared as x approaches 0. And then I'm going to find the limit of 5 minus x squared as x approaches 0. See if you're understanding this. What's the answer to this one? Square root of 5. What's the answer to the one below it? Square root of 5. So what you just did is you did what we said the first thing you should do or try is just plug in zeros. If that works, guess what, you're done, because now up here you have sandwiched this value, and so this implies that the limit of f of x as x approaches 0 is what? Square root of 5. Again, I mean, we could write this junk all day long and you have no clue what we're doing. I would graph this. And, you know, I'll just draw a real rough graph here, but if you graph this, you're going to see what actually happens is this value right here. And why am I going there? Because we said as x approaches 0, this value, if you look at the value right there in between, you're going to see you get about approximately 2.24. And again, just makes it nice if you, do you have a question?
Yeah, so what happens if they're not equal though?
Then we get into that later in the course. Yes. And somebody asked me, what happens if I have to find a limit and I can't plug in, I can't factor, and I can't use conjugate? We get to that. Of course, that's going to happen too, right? Yeah, a lot of these things are, well, what happens if it's not a perfect world, and we will get to later. All right, so I am going to save that. Is everybody okay on writing? No, I just want to save it. So that is MAT1214 semi.